Up until now, we've been looking at different types of functions in which they produce, in many respects, linear features. The flow accumulation grid, what it did was it was useful in identifying streams that we then identified in their stream order. We also looked at flow path, which looked at distance upstream and downstream along a path, along a line. Now what we're going to do is identify regions or areas in which there's commonality, in which everything drains to a common point, to a common location, to a common destination. In this case, we're going to focus in on the Basin tool. And what this does is it creates a raster delineating all drainage basins on a particular grid. That's going to be something we're going to talk about later on. We differentiate between basin and watershed. But basin, what it does is it kind of identifies the regions within a given grid. Where watershed is more, you go in within wherever you want, drop a point, and then from there a watershed is created. In many respects, you could say a basin is a type of watershed, but when we think of this particular method, what we're trying to do is we're trying to create these drainage regions within a given grid that we're using as our input. In this case, our DEM from Story, Indiana. Now, the common drainage point that is found within a basin, it could be into another river, it could be into a coastline or an ocean, bigger water body, or it could be no outlet, internal drainage, or a sink where there's nowhere for the water to drain. Now, later on, what I'm going to do is I'm going to show the output of a basin, kind of really use that to define and describe more in depth. But what we have to do is, first off, think about the flow direction grid. And so this is more of kind of a rule or a preference amongst the GIS and hydrology community, is when you're wanting to do or identify the basins in ArcGIS, it's good to choose to do a force flow direction. So that goes back to a previous step in which we create a flow direction grid. And this time what we do is we actually check the box. And so if you're asked to draw a basin using ArcGIS, the force flow direction option is preferred. And I'm not going to go too much into the details of this, but it's just all about how to handle the cells and how to handle the border or the edge of a grid. Is that the border, or do we think about it how in reality we have a continuous surface when we know things are going to flow off the grid beyond what we just have in terms of our raster, what we just have in terms of our DEM. And as always, it's a good thing to do is to check when we do a flow direction and make sure that we have the 1 through 128, the 8 numbers, and in this case, we most certainly do. So now that I have my forced flow direction, I now have my updated flow direction. I can now call it flow direction 3, and I added the underscore force just to make sure I know where it is and what it is. And then we have the output raster being our basin. And then what we see as far as the result is this particular schematic here. And so this is once again a raster in which you can definitely see polygon shapes though. So we can see these individual basins. When I try to do unique colors, you see here along the edge, there's so many of these small little basins. A basin can even be one cell. So you have most of them on the edge here, but you have these bigger ones that we can see clearly here that in their different colors that we can then really see when we filter in or bring in the underlying DEM. So now the drainage basins have been delineated. You can see them now, especially with the underlying river valleys and stream valleys. And so how these are drawn, how do we see it? And so down here we have, in this particular case, we have a pour point for this particular drainage basin. And so this particular basin has a pour point. And so essentially how this is drawn is the GIS then goes from this particular point and then goes outward, and it's always along the ridge, along the highest elevation here that separates. And so essentially the moral of the story is everything over here in the green flows down this way, or down here it looks like. The greens aren't really distinguished that much, so it flows down this way. Whereas everything over here flows down over here into this valley, and so on. So same over here on this side of the ridge, everything flows towards the southwest, and over here things flow towards the southeast. And so we continue on, we go all the way up, and so we're getting to our higher elevations here in our underlying DEM. So here are our higher elevations. That makes sense that this is going to be the upstream areas of this particular basin. So beforehand with the flow accumulation, we were focused so much on where things come together, these linear features, and also the pour point. Now we're focusing on the opposite, the outer edges, where things are the origins of surface hydrology. All cells within this particular basin, everything is going to be draining down into this one pour point here. And you can filter out a lot of these smaller ones here that kind of really don't have much use for us. And although I'm talking about watersheds next, what differentiates watersheds once again from basins is we have basins are clearly defined here. I put in an input and then this is the output. With the watershed, I could put my pour point wherever I want it. So I could put it right there. I could put it right there. And so then from there, it creates a watershed. It creates a region based off of that one point. So there's a little bit more customization. Whereas instead, the basins kind of force you to use the pour points from the more major outlets instead of any point that you could possibly choose, any cell, any location in this particular study area.